good afternoon. In this session, we're going to talk about progressive delivery with Argo Rollouts, which is part of the Argo project. So quick introduction about myself. I'm Kevin Dubois. I'm a developer advocate at Red Hat. I'm also a Java champion, also part of the developer experience tag, and I'm from Belgium, so far away, long flight. All right, so this is kind of how it started for me a long time ago, and I'm not sure if it was FileZilla. I think it was another tool that was before, but in any case, you know, that's how we delivered our software back in the day, is copy and, you know, kind of dragging and dropping files, or maybe it was in the CLI. I don't quite remember, but it was definitely FTP. Yeah, we had quite a few production outages back then because, yeah, it was hard to kind of test something before it went to production. Not so great, right? And this was even before Git, so we didn't even have version control or anything. So then, you know, we started using Git. Well, first it was Subversion and maybe some other tool, but eventually we went to Git, and that was already great because at least, you know, now we could do a revert and then copy and paste things back and forth. And then we started using rsync, and, you know, we'd write some crazy Python scripts to automate stuff. And still overnight we had outages, and I remember many nights being up to deploy. Then we, you know, kind of evolved and started using CI/CD, and, you know, you probably all have maybe worked with Jenkins in the past, or maybe even today. And you know, so basically with CI/CD, what you do is, you know, you go through this kind of phase of build, test, maybe ideally do some security checks to create a release, and then deploy maybe to staging environment, and then deploy to production. So you have this kind of continuous integration where you build your projects and you make sure somebody commits, and then that gets integrated into the project, and then continuous delivery kind of to get it to production. Continuous delivery typically kind of has this manual process of making sure that, yes, we're ready to go to production, and then we'll actually deploy. But, you know, over the years too, we went from more monolithic architectures to more distributed architectures, and then, you know the kind of the promise of microservices, where you have multiple teams working on multiple projects, which is great. You can, you know, have more granular control over your releases. But that also means that you have many more deployments, right? So in this case, you can see all these little tubes that represent, you know, different delivery pipelines. And it becomes a little bit cumbersome to manage that all if you want to do that manually, right? So if you think of this kind of developer flow, this is ideally how it works, right? You have this inner loop where the developers are doing their development on their local machine or in some cloud IDE maybe, where they're doing their coding, building packaging, testing, maybe some debugging, and then eventually they'll commit they'll push their code. Somebody might do a code review after the pull request, and then you go into this outer loop where somebody will do the code review, then it will be merged, and then a continuous integration pipeline will run. It'll do some compliance checks, maybe build software bill of materials and all that stuff, and then do some tests, and eventually you'll want to deploy. And this kind of circle should be a little bit more continuous, right? So it keeps going as you deliver and release more stuff. So that's how it's kind of interesting, because we call it CI/CD, but really it's called CI/CD/CD because, well, we have the same phases of continuous integration and continuous delivery, but with continuous deployment, we're actually going to automate the deployment of our software as well, so we don't have to constantly monitor it. But to be able to accomplish this continuous deployment, we need to make sure that our systems are robust enough that we have good enough testing to be able to be sure that when it goes to production that we don't need to kind of do manual testing at that point, right? So it requires a little bit of maturity. Now, let's talk a little bit about GitOps that enables that continuous deployment. How many of you are currently already using GitOps, just out of curiosity? So I see like maybe 40% of the room. And how many of you use ArgoCD, just out of curiosity? So more or less the same hands, that's good. So for those who don't know what GitOps is, or maybe you do, and maybe you want a refresher anyway. So the idea with GitOps is that you use Git as a single source of truth, not just for your code, but also for whatever your configuration is, whatever you're going to release to production, and even partly your infrastructure, right? So you define all that in the Kubernetes world, probably in the form of YAMLs. You commit those to a Git repository. And so you can treat everything as code, not just your actual code, but also everything that goes around that, right? And then all those operations are going through a Git workflow, not just for your code again, but also for your releases, your deployment, how many replicas you want, what your instances should be like. Everything can be defined in Git. And that's really powerful because it allows you to not only see what your desired state is and what it should be on production, then it can also be synced on production, but that also means that you can see who changed something, when they changed it, and what was changed. So you have a lot more control over your production environments to see what's going on there, right? So if you kind of compare that with, let's say our classic CI/CD, which we still need for building our artifacts or building our software for testing and everything, but GitOps kind of takes that kind of flow to our production environments where we define a desired state, and then GitOps will sync that desired state with your environment and make sure that that stays in sync as well. So if something changes on production that wasn't defined in your desired state, well, then our GitOps engine, an ArgoCD or another tool, can make sure that that gets mitigated and make sure that your desired state matches with your production state, or at least can notify you that there's something different. So ArgoCD is, I think the most popular tool to do that. It's a declarative GitOps continuous delivery tool for Kubernetes, which allows you to do exactly that, right? It allows you to automatically sync configurations from Git to the cluster and make sure that everything stays in sync, so you can detect drift if there's something that's not the way that you have defined it. Kind of a typical GitOps application delivery model could be something like this, where you have your source Git repository, you commit some code, you build a container image that goes into an image registry, gets tagged and everything, and then your build pipeline can potentially make a pull request to your GitOps repository to change, for example, the tag or the SHA of that container image that you have defined as this is what I want to have run on production. And then once that gets approved, then everything is going to go automatically because GitOps or ArgoCD will notice that, hey, maybe the tag of this image has changed. So let's make sure that we change that on production and pull in that new image. So that's a way that you could potentially use ArgoCD. So GitOps is great. It automates a lot of stuff. But by default, it's kind of a big bang, all or nothing release, right? So you make that pull request. You say, OK, my desired state has changed. Now roll it out. And it's going to potentially also kind of roll it out pod per pod. But it's going automatically from 0 to 100 in production. So we probably want maybe to do that a little bit more progressively. And that's kind of the idea behind progressive delivery, is to make that kind of a step-by-step process where you have a little more control over how you're going to go to production. So what is progressive delivery? It's kind of the opposite of the big bang release. It's a step-by-step. And it also means that your deployment does not necessarily mean the same as your release. So you can deploy something without actually having it run and be available to your users. So you can not send traffic to it, but it already be in your production environment. And then you have control over how much of your traffic you're shifting to this new release. And then you can use metrics to kind of see is everything going well in my production environment on a subset of this deployment to then determine whether you want to release further or not. Or you could also say, I want to release to a subset of users, so I want to only deploy in specific users or that can use this new version, maybe some beta testers or something, and then see how that goes. Why would you want to use progressive delivery? Well, I mean, maybe it's already obvious, but it should decrease downtime, right? Because if you're not releasing, we have a new version, we give it to everybody at the same time, well then if something goes wrong, that means everybody is affected, right? So if we only give it to a certain amount, let's say 10% of your users or a subset of your users, well, if something goes wrong, at least there's less downtime for less people, right? It also allows you to roll back automatically as well, limiting the tragedy of the release and ideally not having to work in the middle of the night to release. This also gives you more confidence to deploy onto production, to release stuff to production. So it gives you more confidence, and you'll likely be more incentivized to release more often to production and have smaller releases to get bigger or faster feedback. And what's also interesting is that if you can use a subset of your users on production, or you can use even maybe your production as a testing environment, that means that you need to maybe use less mocking or set up unreliable fake services to test your services in a non-production environment that might not match with your production. So some delivery techniques of how you would deploy to production. The first one you've probably already seen and perhaps you're using, which is a classic blue-green deployment. The blue-green deployment is really the all-or-nothing switch from one version to another. But it could be, we have version 1 running on production. We deploy our second version. We're not sending traffic to it yet. Once it's stable, then we switch traffic to it from blue to green in this case. And then our green service is now the one that's being used on production instead of the blue. The nice thing about this versus just saying I overwrite whatever is on production is that if something goes wrong, you can quickly swap back to your previous version, to your blue version, if something doesn't go right. But it's kind of a more all or nothing approach. What's perhaps more interesting is a canary release, and again, this is not something new, of course, but the canary release allows you to say, I want to deploy, or I want to send traffic to my new version, but I only want to send 10% or a subset or something, and then see how everything is going, and then we can gradually increase that. And then there's also these dark launch techniques where you can potentially mirror traffic between the two different versions, and you can say, my users, they are going to my blue version, but I'm also kind of mirroring this traffic, duplicating this traffic to send to my new version. So my users aren't being affected by anything that goes wrong there, but I can see how it behaves under real load, right? So we're sending the requests to both. Or you can use dark canaries or feature flags where you can say, hey, this is on production, and we flip the feature flag to enable certain capabilities within our service. So I was at a conference a while ago, and our good friend Victor here, not you, Victor, another Victor, he was doing a talk about mocking, and he's like, well, sometimes it's really crazy how much developers are mocking their services. In this case, the test production code has 4 lines of code, and the test for it has 20 lines full of mocks to kind of mimic whatever is running in the service, right? And then we're not really sure if that really matches with what's on production, right? So this is kind of the cool thing that you can do with production. You can kind of treat it as another testing environment with progressive delivery. So you may have seen the testing pyramid, right? So you do unit tests kind of throughout, and then integration tests slightly less because it's more impactful and uses more resources. And then here, of course, it does not look like a pyramid at all anymore, but we can actually use production as a new testing environment to do, for example, integration tests, load testing, testing of configurations, and kind of getting a better feel of how things are going. Now, how do we accomplish progressive delivery? Because this is all great, you know, it sounds great in theory, but how do we actually do this? On Kubernetes, there's a few different ways that you can do a certain type of progressive delivery. So for blue-green, you really don't need anything more than Kubernetes potentially, because you can just say, I have a service here, point to a certain deployment, to certain pods, and then once you want to switch it to a new version, you just update the labels to send the service pointing to a different deployment or pods, and then you switch traffic that way. You can kind of also do canary releases with Kubernetes. You can just say, my service points to 2 different deployments that both have the same label, and then you can say, I want 3 replicas of my version 1 and 1 replicas of the version 2, and then it's going to kind of send potentially, or ideally 75% of the traffic to your older version, and then 25, and then you can see how it goes. But this is kind of a manual process, right? It's not so ideal. So you can also use service mesh to control the traffic between microservices. You can also use Knative. So with service mesh, for example, it's a pretty interesting solution to do things like fault injection and introduce circuit breakers, and then metrics and tracing between different microservices. But what's interesting is that it also allows you to do intelligent routing and load balancing. So you can do somewhat smarter canary releases and dark launches. So one solution in the service mesh space is Istio. So here's an example of how you would do that with Istio. So you can see here an Istio virtual service, and you have this HTTP route, and then destination of our version 1, where we send 75%. So you set the weight and say 75% goes to version 1, and then 25% goes to version 2. And you can just update the virtual service to send traffic between the two. And you can also shadow traffic with Istio in kind of a very similar way, where you say, here's my destination for version 1, send the users to there, but also send the traffic to version 2 so we can see how it behaves under load. So that's pretty cool that you can do that with Istio. And you can also do like a dark canary, where we say, for example, if the headers of the request contain end user that equals Alexander in this case, our good friend Alexandra is able to use our version 2 to do some testing, whereas everybody else is still using version 1. So that's also a way that you can control the traffic. So that's cool, but you need to still update those custom resources yourself, right? So you need to change those virtual services if you want to change the amount of traffic, which if you're using GitOps, that means every time a new commit, and then letting that roll out. Now, what if we can do an automated way to do our progressive delivery? And this is where Argo Rollouts comes in as a really nice tool to be able to do that. So Argo Rollouts allows you to create a custom resource definition, and then that can work together with a routing system, such as, for example, Istio or Traffic or Nginx or whatever you want to use. And then that's going to control how many pods are being deployed and how the traffic should be flowing between our different versions. And then we can also monitor our traffic to see what's going on in there. So an Argo Rollouts custom resource definition looks a little bit like this. So you can see here the kind is rollout, and then we have this strategy. And so you can do a blue-green strategy, but you can also do a canary, which is what we're going to focus on here in this session. And in this canary, we have steps. And in these steps, we have certain weights. So we have our first step, where we say, weight 20%. So the weight is not weighting, but weight as in the weight of something. And in this case, we send 20% of our traffic to our canary, which we have defined here as canary service. And then we set a pause, and in this case, it pauses for 1 minute. If you're working in let's say, a production environment, it might be a little bit longer. For my demos, 1 minute is already long because I have to wait that whole time. But in a real environment, you probably want to wait a little bit longer, make sure everything is going well. And then if everything is going well, but then we set the next wait for, in this case, 50%. And we send 50% of the traffic to our canary. And then we pause again, and then potentially we set another wait for 100%, and then we roll out completely. So the nice thing here is that everything, that whole rollout is going automatically. So you can go from 20%, wait a while, everything is going well, it's going to automatically send more traffic to the new version, and then continuously until we're fully on our canary version, and that becomes the stable version. And then, but this still requires a little bit of a manual intervention if something doesn't go right? Because we have to go see if something doesn't go right, we have to go test it. So what if we make this a little bit more smart and use the data, the metrics that our applications are producing to see what is actually happening in our application? So this is another component that you can add to your Argo rollout strategy is this analysis. And you can see here we have an analysis with a template that's called success rate. And then this template is also a custom resource definition where we can define what constitutes success in terms of our release. And this is something that you can define yourself. So in this case, I just gave an example where we say, success means that 95% of my results are successful. And what we're doing to determine that is we are using, in this case, Prometheus. But again, this could be a different provider as well. And in this Prometheus query, we check for 500 errors. So if the response code not equals something that starts with 5 as the response code, then it's a success. So unless we have more than 5% errors in terms of 500, then everything is going to continue going step by step until we release. If, however, there is more than 5% error rate, then it's going to automatically stop the rollout and roll back to the previous version, except I set here failure limit 2, so I'm allowing 2 checks to fail before I actually roll back, just in case maybe there were some false positives. So should we look at this in an actual demo? Because it's always more interesting to see demos, right? All right, so here I have this rollout, right? So you have the rollout. I'm using 10 replicas for my deployment. And you can see here that I have my canary strategy, and then I have an analysis template with success rate, just like in the slide. And here you can see the different steps, right? So we're going to deploy to 20%. We're going to wait for 30 seconds. We're going to then roll it out to 30%, wait 15 seconds, then to 60%, and then to 100%. And then here you can see the template, and it's exactly what I showed in the slide too. We're going to look for 500 errors. And so here I just have this simple customize where we are going to roll out. In this case, we're sending it to blue, and here you can see the demo. This is exactly, if you go to the Argo Rollouts project, you can actually find this demo as well. And it just shows these little squares here. So it's sending little requests for each one of these squares. So these are all little JavaScript HTTP requests to get what color is in the back end. So right now it's all blue, right? Now I'm going to start my Argo rollouts. You can also monitor your rollout. So you can say get rollout of type rollouts demo. And you can see here that we have, I've already released a couple of versions, but we're on revision 8 right now. And we see that there are 10 pods, and everything is going great. Everything is healthy. Now I want to release a new version. So let's make it, let's go to red as a color. I don't know, it can be any color, but and then I'm gonna say I'm gonna let's pretend that I made some code changes, right? And I'm going to commit them straight to my main branch, of course, because that's what we like to do, no peer reviews or anything. Git commit change to red, and then I'm going to push that. And then because I pushed that, now there's a change, and so our GitOps is going to, our ArgoCD is going to notice that there's a change here. Let's go here to our canary app. It shows that we're out of sync, and now it's going to start rolling out the new version. So here on the left side, you can see this canary popped up, and it created 2 pods. And now we're starting to send some traffic to our red, right? So you can see that some of the requests are returning color red instead of blue, and this is 20% to start with. And we're going to let this run for a little bit to gather some metrics in the back end before I start doing an analysis, because if I start doing an analysis before I have data, then potentially it's going to error out. So let's give this a little bit of time, and then we're going to see that in just a little bit. We're now sending a little bit more traffic, and we're also doing this analysis run here, right? So you can see here, analysis run, and we can see a green check mark and a second green check mark, which means that our release is going great, and there are no errors, or at least not enough errors to cause any issues. So we can see that everything is going well, so we're sending more traffic. So now we can see that we are at weight 60%, so 60% of the traffic is going to our new version. And so it's gradually sending more and more traffic to the new version, and you can see more and more of these red squares appearing. And then in a little bit, we'll see that we're going to create even more pods and sending more traffic to our newer version. And then let's make sure that this stays up to date right here. Sometimes if you don't scroll all the way down, then it doesn't keep up to date. Okay, and now we have 100% of our traffic going to red. We can see all the squares are red, and now our canary is stable. And you can see here, our previous version here says there's a delay, and it's counting down. And so it's just waiting a little bit to make sure everything is going well, allowing us to still have some time to roll back to the previous version. And if not, now the delay has passed, and all those previous pods are terminating, and now we're fully on the new version. Now, what if something doesn't go right? So let's change it to, for example, yellow. I'm going to do another commit. And then let's give the little bump here. And soon we'll see that our new release is happening. So now our yellow release is going to happen. And we should see a little yellow box appear here. And I'm going to now set an error rate so that it's going to basically mimic that there are 500 errors happening in the back end for the yellow. So you can see, maybe if you have really good eyes, there's these red squares around some of these yellow boxes, which means that they're returning errors. Now, our analysis that's going to run is going to notice that the rollout is actually not going so well, right? So it's going to notice that some issues are happening. Oh, well, in this case, it's a green check mark. We'll see if the next one is red. If so, I set it to maximum 2 times there can be an error. So right now we have 1. Once we go over the 2, then the Argo Rollouts is going to say, this is not a good release. We should roll back to the previous version because this is not going well. So our users are only partially affected by this issue, and we're automatically rolling things back. We did not need to manually intervene, right? So here you can see that our status is degraded, and we're going to see that our yellow squares are going to start disappearing because we're sending all our traffic back to red and automatically rolling back. So that's what you can do with Argo Rollouts. So that was a quick little demo of what you can do with Argo Rollouts. Another thing that you can do is add an experimentation step as well, where you can say, hey, I want to just experiment with different versions, maybe like an A/B test or something. So you can, in those steps, add an experiment set, and then you can also define, I want 5% to this experiment. So I hope this was kind of a nice introduction to Argo Rollouts. And final notes, of course, this is all cool if you want to do automated releases and split traffic, but of course, if you have state behind it, make sure that if you have traffic going to different versions, that your state is handled. That's a whole different talk, but it's definitely something to keep in mind. With Argo Rollouts, you can do step-by-step releases. You can embrace GitOps. And as we always say, if you haven't automatically destroyed something by mistake, you aren't automating enough, right? The links for the demos are here in the notes here. I'll share the QR code for the slides. There's also some free ebooks that you can download. You can get those with the slides here as well. So that should be a link to those slides, and you can review it. And then you can always reach out to me on those channels. I'm happy to also take questions after the session. And with that, I thank you for joining the session.